So when Rick first came up on the stage, he did the thing, wow, I'm a veteran, I've been 10 years. Well, it turns out I started at Transport for London 18 years ago. But the joke there is that when I took the job, which was all about performance management, I started the job, and it turns out the first data set I was given was only 24 points. That was them collecting the journey times from floating cars. And I thought, I'm here for a job, I've got 24 data points, what do I do? And then I realized, it came to me, I actually have to build from scratch. I have to develop this job. And that's what happened in principle. And that is, the journey I've sort of taken to eventually get to this digital twin. Lots and lots of things have happened on that journey. But before I started at TFL, my background is as an ecologist. I started my work in theoretical ecology. I started in fisheries management. I've always been interested in complex systems. And that's my skill set, actually. My skill set is bringing problem solving to essentially complex systems. And there's no more complex system than actually London's roads. And this is my take on the proof of concept that we've built, this digital twin for London's roads. So just bear with me, I'm a bit new to this. So this is an outline of the presentation. I just want to take you into what I think of as a digital twin, a bit of a definition, and I've got a simple model of a digital twin after that to sort of explain it. Then I want to explain a bit about the context of London's road space. What led me? How did I get to this assumption that I needed a digital twin to solve the problems? And then how did that lead me in terms of my problem solving skills to unpack that and generate a new paradigm? And then essentially, I want to demonstrate via a video a demo of the product that I built as a proof of concept, which we demoed when the ULEX zone went live in London on October 25th. And then I want to take you through my construct of the digital twin, which are 5 layers, and how I've built it and how I've actually put that together. And one of the things that I would like to take away from this is, if I meet any of you in the room or in the questions after, is actually your take on what I've done, and your understanding, and if I think, any thoughts about whether I can do it better. And then I'm going to take you through next steps, and then my thoughts on what I think it takes to deliver a successful digital twin. What we know academically is that this subject of digital twins is very, very hard to implement. There are very, very few successful case studies written up as to what constitutes a successful digital twin. So I have a definition here, and I've particularly chosen this definition because for me it gets to the essence of what I think you're trying to get to when you deliver a digital twin. So it says here, a digital twin can be defined as an integrated simulation of a real-life system that uses models, sensor information, input data to mirror, predict, and control the activities and performance of its corresponding physical twin. And the essence of what I'm talking about here in the digital twin is there is a connection between the physical world and the virtual model you're building, and that is done by generating real-time data. However, when it comes to digital twins, not everybody has a simple definition of what constitutes a digital twin. It is essentially one of these difficult areas where people have very different takes on what constitutes a digital twin. And I've put this simple model up here to actually think through that essentially what often people have is a digital twin at a different stage of development, or there's a maturity model that actually digital twins go through. And so there's these different facets of a digital twin, how autonomous it is, how intelligent it is, how much it undertakes its own learning, and then all these elements of fidelity around the level of detail that you've got in your digital twin, the number of parameters, how often it synchronizes, and actually its level of detail and accuracy. And what I've drawn out there is these sort of 5 levels of actually the maturity model of a digital twin. So if you're at level 1 here, you just might have a basic model of a map. If you get to level 2, you might have some capacity for some feedback and control. You've actually done some connection between the physical world and otherwise. And then at level 3, you provide some predictive maintenance, analytics, and insights. And then at level 4, you have got to the stage where your digital twin is providing recommendations in real time of how you want to maybe interact with the physical world. At level 5, we're not quite gotten here because that's about autonomous reasoning and replacing humans, which is why I'm probably a little bit greyed out towards level 5. And my proof of concept, I think, is about level 3, just past level 3 on this particular model. And what I'm aiming to do is deliver a decision support system for the control room in Transport for London's roads, so that actually we can basically use that in real time to actually modify how the roads are running. And the other thing I should say is, not all digital twins have to be everything, all these elements at the same level. They can be at different levels. But the idea is that it depends where you are on your level of maturity as to how you describe what your digital twin is. So I've talked about complex systems and roads. And roads ultimately are one of the most complex things to manage. I've got this picture on the left which gives you this, this is a snapshot from one of our AI digital cameras on the network. This idea that it's fully multimodal and we're trying to balance, access and use of the road space. And then this little chart on the right, I'm not going to go through this in detail, but it gives some idea of the complexity of the road operation. Everything from manage every bit of the assets, to running the bus service on it, to managing 50,000 roadworks a year, to managing 3.7 billion road trips of different types of, by different modes. And what we do in Transport for London in Surface is we manage every single element of that, from managing the 6,400 traffic light signals, and they are fully sort of automated and regulate most of the activity on the network, right through to managing all the assets and everything that goes into making the roads work. But there are specific challenges about London's roads that actually make them truly a complex system. On the left-hand side, we have data. We have poor quality data. Like I said, when I started 18 years ago, there was nothing. In some areas, like monitoring freight movements and PED movements, we still don't have good data. We have poor spatial and temporal coverage. We have a lack of certain types of data. We have poor innovation by suppliers in terms of sensors and new data. All of these digital AI cameras are brand new. We've only been out trialing them for 2 or 3 years. I now have about 150 of them on the network. And, this whole idea about we understand our outcomes, but we don't necessarily understand what's driving them. How do I bring that information together? That's what's really important. But there are attributes of the network that make this complicated. London's roads are open. They're not like, running the underground or a bus service where you have a schedule or a fixed route. We don't manage demand per se. It's an open network. The road layout is very atypical. Every single road's different in terms of its characteristics, its physical entities, how wide it is, how much capacity it is. And there are constant dynamic changes in the network design and layout. I've estimated that 10% of London's roads have some facet of change associated with them. In other words, either there's some element of redesign, resurfacing, or some elements of control are changed on that part of the network. And one of the key things is we still fundamentally don't know how to manage demand, or how to measure demand and capacity effectively. We have proxies for them, but there's no single, my boss says, essentially I provide supply on the road network, I supply capacity. But do we know how to effectively measure it? Because there are so many things, so many facets that go into that. We also have stochastic properties. It's human behavior driven, rubbernecking, things like that. A network can operate at 2 different flow levels, just essentially because of these types of stochastic properties. We also have this property called emergent behavior. The minute something happens on that network, you intervene on that network, that intervention itself is changing what happens around that network. And so these are things that begin to me, in my mind, my problem-solving mind, already telling me things about how I manage this problem. This isn't a simple engineering optimization problem, for example. So there, I'm reading lots of cues in this about how I then go on to think about my digital twin or develop it. So I'm sorry about the color scheme I've put there, which means that it's not showing up as well as it could do. But there are some business challenges here, and your problem space is defined by your properties that you're given. What are the challenges? What's the background? What are the boundaries of the problem that I have to solve? I've got disparate data sets, but the business is saying, I only want one version of the truth. I don't want different data sets telling me different answers. So this tells me I need to start thinking about a framework to align the data. I need to explain the outcomes. We're very good at outcome measurements. I know exactly what your journey time was or how much delay you had. What caused that? Was it a change in demand or the weather in an instant? It's not connected. I don't necessarily know. That means that I need lots of metadata, and I need to connect all that data up to make the connections between the drivers. Real-time data. I need to be operationally effective. I actually need to process data in real time. I need to have operational responsiveness. That's the business need. But how do I respond? I begin to think graph databases. I know a relational database can't effectively manage data in real time. I have very, very many different modes. We've moved from a car-based model to being truly multimodal, thinking about pairs, thinking about cyclists. And I have multiple objectives set to me by the mayor around safety, air quality. They don't necessarily align, and these objectives move depending on location and time. So I need a sort of an agile and adaptive response to deal with that. We've got a lack of sensors. So there's this constant improvement in data, like the digital cameras coming on board. How do I bring that data in? So I need to think about scalability and data fusion. I've got these changing objectives. So like I say, I might be able to need to flex a particular piece of road space to do different things by time and day. At daytime, it might be need to flow in one direction, nighttime flow in the opposite direction, for example. And then, and so there I know that to deal with those levels of objectives, I need very low, I need granular data, I need very detailed data. And I also need trips and routing. So how do my customers respond when something happens on the network? And so I know that that reassignment problem is best answered by a graph database. So again, this is just an example or a set of examples, but I've been through a fine-tooth comb all the boundary problems that I have to solve. And the normal paradigm that you would adapt if you were in my position to think about doing this is that you would think about adapting your current business architecture. You might build a bespoke application to answer some very specific set of requirements. That's typically what happens in the rail industry, which I was in before I went to TFL. Then you get scope creep and you get an over-engineered solution, and it becomes quickly redundant. But we've got new technologies, new capabilities. We've got cloud services, we've got graph databases, we've got open source software. I've got access to data scientists. So my thinking was, let's develop an alternative paradigm. Why don't I turn this on the head and develop something that can answer 90% of my business cases? And I can respond to all those needs that I brought out in the previous slide, and I can answer a range of complex problems. These problems that we're looking to solve are complex and forever changing. So I need to scale and adapt to new data sources and different road contexts. And this is the thought process that led me to build the digital twin that I'm about to show you. So underlying this, my work is the proof of concept for this. And what happens within TFL, we have a large technology program called the Surface Intelligent Transport System program. And what we're trying to do is move from this, where we've got all these disparate systems, urban traffic control, Scoot, the algorithm that runs the traffic lights, the cameras, signal fault management. And what we're trying to do is move to this, there's one version of the truth. And I'm in charge within TFL as to two parts of this project. I'm the business owner of the data roadmap and also the data service hub. And then what we're trying to do is connect all this data up to run a number of services coherently in real time. We're replacing all the signal system, which is what RTO is, real-time optimizer. That signal system now will be truly multimodal. We are producing a common operational view of the road network. This is the decision support system that I will talk about, that the controllers will use for their information to manage the network. And then we're building a predictive capability module, which will be able to take a snapshot of the road network, run it against traffic models in faster than real time, and come up for mitigation measures. So that's our road plan, but what underpins it? You need a coherent single set of all the data to tell that one vision of the truth. And that is the digital twin that I'm about to demonstrate, this proof of concept, will become this operating model, the decision support system for our technology program. So this is a snapshot of the digital twin that I built. I'm going to take you through a video of this, but this single slide actually says that it was utilized in anger when we had the implementation of the low emission zone inside the outer ring road. This went live in October the 25th last year, and I built this tool for the signal engineers to be able to understand when there was an incident on the network. And you can't quite see here, but there are some defined areas like Chalker's Corner they were very concerned about. Some other areas that specifically, if we had overlaps in those areas, they would act on this information instantaneously and switch the signals and switch the signal plans as this information came to light in literally minutes. The good thing about this is the proof of concept was this detected 5 incidents on that particular morning that the control center didn't pick up. They use eyes on the network, CCTV, and typically there's a 15-minute lag in detecting incidents on the road network, and we did this in minutes. So I'm just going to play a video here, which I'm going to talk over. So this is the digital twin. We can see up here in the top left, it gives you information about its refresh. At the moment, what we're doing is we're bringing through journey time information both for traffic and buses. This is basically relative to a baseline just before the ULEC zone went live, telling me where there is disruption on the road network. The red means something in terms of the amount of delay I'm seeing relative to before it went live. I can drill into different areas of this tool. Here I'm looking at Westminster. So we have the ability to focus in. So we're just going a cut of the data for the inner zone. You can see the blue bar at the bottom is telling me that data is refreshing as I'm pulling this through. And then we have lots of contextual information. I can run over this link and I can see in real time what's happening there in terms of absolute change, the difference in journey time, giving me some absolute sense of where I'm at the network and whether I need to take an action. So we've got here what my journey time deviation is, sort of all the contextual information the signal engineer needs in real time. And one of the things that we're effectively doing is constantly comparing buses relative to general traffic, because our job here is to protect bus services. And here I can see the route numbers, and differently here, I can see their deviation to the actual schedule time in real time. How slow is that relative to when the bus said it would be here? I can bring up information on what's being recorded live in the control center. I have contextual information on all the incidents. I can see here that we have a gas replacement works on the go. Here we have 4-way traffic signals operating at that moment in time. So I can begin to sort of bring up lots and lots of contextual information. I can also see the flip side of the very delayed part of the network. I can actually see where I've got spare capacity. So all I've done here is, instead of focusing on where I've got congestion, I'm actually focusing on where the journey times are flowing quite freely. Is there something here that I might have in terms of being able to reroute traffic? Do I have some parts of the road that are more free-flowing, for example? The way this works in principle is it works on the basis of thresholds. Basically, there's a percentage difference on the amount of journey time in these links relative to the baseline. But one of the things that I can do is filter this journey by using and changing this threshold at the bottom. And what that does is it basically allows the operator to focus on the bits that are absolutely critical to focus on. So be able to get a full overview of the journey times on the network, but also to focus on a threshold of what's the important ones to manage. So I talked about the 5 layers. The first layer here is about data. You need to assemble your data correctly. And one of the things that I did in line with the new paradigm is I went through all the business requirements that we had gathered across the business, all our customers, etc., understanding that there are key roads dimensions that I need to grasp, like journey times, flows, trips, and all the necessary metadata. ODs here means origins and destinations for your trips. And I looked to see what is the thing that the business is trying to look for, the outcome, and basically dissected out each element. So for example here, and I'll just concentrate on the one under air quality, my boss wants to know emissions. How much emissions are coming out from vehicles? Air quality is a more complex thing than the emissions. It's emissions plus what else is happening in the environment and weather. But essentially, if I can basically provide him level or a map of where the emissions are, he can do things with signal control or to manage where those emissions are happening. What I know, or what I need to know, is I need to know acceleration, deceleration profiles at the 1 second level. I need to know the mode share, and I need to know something about the demand on that link and the journey times. And what I'm doing is saying, what's the lowest level of granularity I need to hold in that digital twin to answer this problem? At what scale, and also geographically, what scale as well. And then I break all my problems down like that. Is it a link problem? Is it a link conjunction problem? What level of data do I need? And so it's about reassembling that data. So what data do I have in my digital twin currently? We have the general traffic journey time data, which is what I was illustrating in that demo. I have the bus journey time data. We can compare and contrast how successfully we're managing one against the other. We have this mission to protect and make sure that the buses are running smoothly against their network. I understand the signal patterns. We have quarter-second detail coming off of our Scoot system, which tells me something about flows and congestion. I have information on roadworks and incidents. And this is all in real time. So think of the digital twin as a processing engine in real time, but I also can archive this off. So I have all this historical data. We tend to aggregate it to the 5-minute level, and we aggregate it over 60,000 links across London's roads. And I've got 30-odd billion roads. It's about 150 terabytes of data at the moment. So it's fairly big data that we're working with here. And what's the future for this product? What's my aspiration? My aspiration is to bring in the information from the digital cameras I've talked about. A whole host of new ANPR, automatic number plate recognition cameras, are going out, which will enable us to understand flows better. Social media data, Waze. Freight telematics data, we're working with DHL and other suppliers. We have some trip data from one of our suppliers, INRIX, which I need to work out, and then the new RTO signal system will provide more insight as that system goes live in the next year or so. The aspiration here is to be really fully multimodal. The second part of the graph database is thinking about how do I organize that data. So I've talked about the data and collecting all the data. I need to think about how I organize it. And frameworks are important because frameworks are where you think about how to solve your problems. So what we did is we developed a framework which we called the Common Operational Road Network. And it's different from the level of detail that you would get in OS highways. It's a sort of an aggregation in that, and the average distance here is 200 meters. And why did we settle on that? Because we did some tests and we found this is what was computationally efficient. This is the appropriate scale for operational reporting and road network control. It's important because if you're visualizing this data, it's got to be meaningful. So we define a network, and what we begin to do is we ask our suppliers now, our data suppliers, to snap their data to that network. And we understand, as I've said, that the road network is dynamic, so I need to refresh this. And we have a process internally where I refresh what the network looks like. We use what's called an FME workbench in my GIS team to do that. And essentially, we basically provide a refresh network to our suppliers every 6 months and say, snap your data to that. That's our latest view of the road network. So we're beginning to bring in these elements of dynamic control and dynamic change. But frameworks are really, really important. You need to think about how your business requirements are processed. And what's the value of the framework? It's alignment. It brings together all this disparate metadata you've got all over the place. I've got 240 different layers that describe the road network, everything from where the asset is to where the bus stops are. The framework aligns the data. It enables you to have an output function and those output functions to deliver business needs. I won't dwell on that slide. It's essentially a processing layer. Then we come to the heart of the digital twin, and you've designed your framework, you've thought about how your data and your framework work together to solve the business problem. The key then is to align your graph database to your framework and model the road network. So I include all my contextual metadata, I can map all the key relationships, and then I have this virtual model of what's actually happening out there. So each of the 60,000 links I've talked about in my framework is identified by a node. In this graph database, that node knows everything about my metadata, everything about what's connected to that node. But the smart thing is that node also knows how they relate within the network to the node next to it. It understands what patterns you need to follow to get from one node to another or to go through the network. And those, because all that information is set out for you, and those relationships within there are directional and mimic what's actually happening on our roads, it allows millisecond calculations in real time. I can ask it, given its contextual information, all the information I have stored there, I can ask it, what's the journey time, this instantaneous journey time between where I'm sat here in Barnes to Putney Bridge, and it can calculate that in milliseconds for me. And the other key thing for me is that data is now aligned spatially and geographically. What that means is that I have all the contextual information to do the explanation. The journey time dropped. Was there demand there? Did I have an instant? Did I have an instant further up the network? All the alignment of data finally brings us together, and I couldn't do this job without the graph-based database technology. The primary business case for the development of our prototype was actually the detection of incidents. I demonstrated it a little bit by how we did that using the INRIX data. And what we're doing here is we're developing what I showed you earlier and taking it to the next level by using the analytical functions that are within the graph database to actually define what I consider to be an incident. We are basically using this technology to cluster together those journey times to look at finding where the boundaries are. We can find the centrality of this incident. We can define a boundary around it. But we can also understand how the traffic is routing through the network as well. And we get a real-time estimate of the impact of this. Because I have all of the journey times, I will know the flows on the same network. I can instantaneously apply an algorithm that says, what's the value of time for a customer at that time of day? And it will tell me that congestion there is worth £100,000 just for that instant. And that information will flag up. You've got an instant here. It's worth £100,000. Do something about it. The fourth layer of the digital twin is about how do I take all of this information and make it real for humans. And this is actually something that I hadn't anticipated, but actually it's one of the most interesting areas, but also one of the most complex areas to get right. So when you have a digital twin and it's processing real-time data, you've just got data flashing at you like this, and you go, how do I make sense of all this data? Well, I have to make that data real. I have to make it representative. And the way I do that is I found initially, I actually have to slow it down somewhat. I do that by putting some form of moving average through it. I make sure that I have the right contextual information, that I have the right standard deviation benchmark threshold relative to the baseline, that I'm getting the right cutoffs that make an incident worthwhile. And the reason for slowing it down is I have to ensure that that incident is persistent enough. It's not a fleeting mirage of just somebody stuck temporarily. I have to make sure that it's something that's representative. And how can I do that? So the cognitive efficiency partly comes from the design. I mentioned about designing the Korn framework. We did the initial work there. We know spatially what we have to do to make that cognitively efficient. We also know that we need to keep it simple. Humans can't understand more than 7 different colors or different interactions happening on an interface at the same time. So you have to keep it simple. One of the things I demonstrated there was toggling a data layer between the buses and the traffic. I can also scale the information, I can color it, I can change the road width, but I'm trying desperately to make that easy to understand for a human. We did a number of tests in presenting this. I can also do things like partition the data by meaningful thresholds. Like I showed you before, I can provide controls for the operator to change the thresholds. And the example here is actually I can provide a data label and I can put a lot of the contextual information in there. So I think some of the issue that people have with digital twins is like, how do I represent all those dimensions? And I'm saying with clever thinking, you can actually do a lot of representation, but be very careful about how you think about doing that, making sure that you understand that real people are using this. What I have here is another video. This basically tells you something about the importance of actually having data in a way that visualizes it. What this video did was look at changes in flow as detected by our traffic signal system just prior to when COVID hit, and then we can see what the impact of COVID was on flows on this network. So here you can see I have reasonable flow levels across most of London, and then about March the 15th, we begin to see a bit of blue, and when we get into deep blue, traffic levels have fallen 50%. And that was the impact of that first wave of COVID. And just being able to visualize that, and then coming out the other side, through these visual sweeps in time, we can begin to understand how the road network began to recover. But this is the idea of being able to play visualization with your data and being able to understand what happened on the road network. So as we come into May, the network's beginning to recover. The 5th layer in my digital twin is this idea about how can I get it to do a lot of work given that I have so many contexts to answer. I have to answer the context of measuring emissions. I have to manage the context of situational awareness. And there are so many things, so many rich things that can be done with this underlying data set. There's so much metadata there. So we came up with this idea of a modular design that allows for partitioning of the workload. The graph database and the underlying digital twin are doing the real-time processing and the preparation of the information, but where you need to do further work and develop algorithms and apply those algorithms can be done in the plug-and-play unit. So we've basically done some work on a proof of concept for air quality emissions. We've basically gone and developed this idea of working out these 1-second intervals of acceleration deceleration profiles on links. That information goes into a FEM model. That FEM model, which is just an acronym for a model that basically produces the emission outputs, then produces a map like this, and that's done in a separate layer. The situational awareness is something that I demonstrated to you earlier. That was the digital twin itself. And then there's also this idea that's been developed in our modeling team of an operations live planning tool. One of the things, again, about our customers need to understand what's happening. We have this idea that we can use an Oculus, we can get people to understand the layout of the digital network by providing 3D visualizations of the network based on our underlying traffic models. But what this tool is doing is it's pinching data from our underlying digital twin, and basically providing context for people to go out on the road network and do virtual planning. And I have a video here that takes you through that.
When roadworks are carried out on the network, more often than not, a site meeting is required with multiple parties, which can prove difficult to organise with everyone's busy work schedules. That's why TFL have developed Operations Live, which enables everyone to meet in a virtual, real-world environment and provide them with the information they need to make business decisions without the need to meet in person. The Operations Live app does this by converting traditional 2D datasets into a 3D interactive digital twin of London, which can be accessed via a web browser and used with online meeting technologies. This allows us to gain a greater understanding of our data and how it relates to the real-world surroundings, as well as enhancing communications with our stakeholders by removing the barriers with this type of activity, like organising calendars for large groups, time spent travelling to destinations, risks associated with conducting site meetings, and conveying relevant data to stakeholders with varied areas of responsibility. Additional datasets are in the process of being added, which include permits, utilities, accidents, Google Street View, jam cams, traffic flows, urban traffic control elements, and many more. Operations Live aims to reduce the requirement for people to attend site when carrying out initial assessments of proposed roadworks, increasing efficiencies within the planning stage, and allowing us and our stakeholders to target the data that matters. This project was made possible by funding received from TfL's Lane Rental Scheme.
So what I want to do now is just talk through what our next steps are. I talked about the development of the digital twin for instant detection. We want to develop the use of the graph technology across the different data sets to provide real-time connectivity and alerts across those data sets. So the thinking is here, if I have an alert driven out of general traffic time, but I also have an alert from the bus journey time and I also have an alert from the scoot journey time, I can get them to reference each other, confirm the probability of an alert is higher, and therefore reduce the idea of we have a false alert. We want to develop this as the decision support system in the network control system, management control center. Essentially, humans will interact with this, make changes to the network, make their decisions on what their actions are, whether they change the signal plans, whether they connect to the police, they connect to any other service to go out and do something on the road network. And then we also want to develop Operations Live, the 3D system, and we will be working with the modelling team to do that. Those are our next steps. What I wanted to do was bring together my thoughts around the development of the digital twin. What I think it's important to be consider when you're thinking about building a digital twin. I think it's important you stick to the principle that the business only wants one version of the truth. That's critical. You need to be clear in understanding the path between your data, and the delivery of the business objectives. If you haven't done that work, it's not productive. Do not overreach what you think a digital twin can deliver. It's enough complexity to do the simple business cases. I've got round some of that complexity by the paradigm I've invented and some ideas of the modularization, but I still think there's limits to what I can do with that digital twin. You know, everybody's saying, could I run a smart city from it? Not currently. One of my pieces of advice is to invest heavily in developing your metadata. Without your metadata, which is all the contextual information that allows you to describe your business, describe the network, if you haven't done that work, you can't just adapt technology and plug in new data. The context is important. Think through what the graph database can deliver by its additional functionality in connection with your metadata. You can leverage your metadata through your clever understanding of what the graph database can do for you. And think through how a modular design, I've got 5 layers in my digital twin, by judicious recombination of the elements of that, can do to provide for multiple outcomes and answer more than one business case. And the idea I've got in my head is essentially the way that I've set it up ultimately simplifies my architecture overall. And my key message is success needs strategic alignment of those different layers. You need to have done all the thinking. You need to have connected your data to your framework. How's your framework using that data going to address the business problem? Actually, in TFL in my land, I have more than one framework. I can switch more than one framework in and out to answer different problems. That's part of the modular design. The framework's really important because it aligns your data. And the actual alignment of the data enables you to answer many more questions. It enables you to normalize data. For example, if I've got road safety data, road safety per how many journeys, how many kilometers of journeys, etc. It's that thinking through about how you utilize your metadata to answer your questions. You must have then a strategic alignment of that framework with your graph database. The two things need to work in conjunction. And then you have this visualization layer, and then you need to pay very special attention to how people interact with that data, to utilize it, to understand it. Because the first attempts we made, we just got laughed out of court because they just couldn't understand what was happening on the screen. Yeah. And then there's this idea of the plug and play. Does a modular design partition the workload, enable you to think through and take away the strain of trying to do everything in one's big application? And those are my thoughts and the best of my knowledge in what I've done to develop our digital twin for London.
Thank you all for the amazing presentations. Andy, I mean, really fascinating what you do. So my name is Maximilian Weidel. I'm the CEO of a company called Next Boardroom. We are an executive community using graph technology for maximizing network synergies across our community of executives, CEOs, entrepreneurs. We've been using Neo4j now so we're a startup. We've been working with Neo4j with the models for the last 4 or 5 months, and we've done sort of the steps Andy described around structuring the framework and then designing the graph model and utilizing the algorithms, etc., for different use cases we have. And what we experienced is that actually the design of the graph itself varies depending on the use case. So we end up actually experimenting a lot. We have to experiment a lot, changing the entire way we think about our graph and the way we think about our data what's a relationship, what's a node, etc. And that's taking us quite a lot of time. So I'm really interested, especially Andy, with your level of complexity you're working with here. And I understand you put a lot of time into your frameworks, but translating that into your graph, especially considering all the changes with new technologies coming in. Basically, the question: how often do you have to redesign your entire graph? How much experimentation is going on?
Thank you. Sorry, we need to run around here with some microphones.
Yeah, thank you for the question. Can you hear me? Yeah, thank you for the question. The honest answer to that is, as part of that problem-solving process, quite often is the answer to that. And the reason being is that you find that you haven't thought things through then that you know that you need later as your levels of complexity build up. However, if you've done some really clever thinking about what are the key elements that you want to bring out, and you already have them partitioned by your nodes, you can often do that by some clever recombinations of the data that you hold. So there are occasions that you need to re-optimize the graph as you sometimes bring in the layers. So for example, there might be a requirement to understand bus schedules. All of a sudden we're going to redesign all the bus schedules, and we haven't thought about that, and there's a new way that bus schedules are going to be delivered around the network. Yes, we might. And I just think you have to accept that as part of a process. And probably me more than most cases, because the network's so dynamic and what you need to do, yeah? I hope that answers your question, but it's part of the process of, yeah.
If you don't mind, I'll just add, I think it's wonderful that you can do that, right? I mean, if you ever use other types of data technologies, you know that it can be extremely painful to change models and to, all of those types of things, right? So I think it's one of the fantastic characteristics of graphs that you can, in fact, quite easily change your model and even have multiple models in the same database. That to me is actually why I think that graphs are such a great fit for agile software development. If you think about 3 week sprints, and every 3 weeks we're doing a new thing, and we're delivering. Well, you know what? This fits that bill really, really easily and really neatly. I think it's wonderful to be able to do that.
Yeah, there was an interesting conversation we were having with, again, finance, a Canadian bank, right? And they were moving towards this microservices world. And what they ended up starting to think about was, when you think about microservices, sort of decoupling everything, right? So that you've got one API, there's one microservice accesses one set of data. And we ended up getting to the conclusion of why then do you have this massive monolithic data store that sits underneath? So what they ended up doing was looking at building a perfect model for that question, right? And this is where obviously you look at the hosting, the way that we can run these databases in Neo4j, etc., on top of Kubernetes and all these frameworks that make it super simple to spin up multiple databases, multiple instances of it. Some cases it just doesn't make sense to do that. Now obviously when we start getting into, we talked about the customer 360 part, this is where certain kind of caveats and pieces of the Neo4j technology, something called Fabric, allows us then to kind of, again, if you want to, merge those multiple kind of installations. So yeah, it's like anything, right? Very rarely do you get the one perfect model, right? Machine learning, you can have multiple kind of algorithms just doing a tiny bit of that work. But yeah, it's this is why for me it's always start with a business question and re-engineer it backwards, right? Not trying to, what we like to do as engineers is yes, great shit, I've got all this data, I'm going to engineer something and realise, Christ, it doesn't even answer any of the questions I wanted. And so yeah, for that, you look at it, that iterative work, and it's simple. I was with another customer and I was whiteboarding on Zoom, mapping out there, just what data have you got, right? And they literally had a CSV headers. And we were literally drawing the kind of the architecture out. And then he asked one thing, I was like, right, we need to redate the whole of this. Because you've asked that certain question, that relationship between, in that case it was fraud, you need to then have this way of linking those two people together, right? And that's the iterative approach you need to take to any modeling, let alone whether it be graph. But yeah, it's an interesting world.
Any other questions?
They just want to go to the bathroom, I think.
I know it's been we kind of run over a little bit this morning, but we've got a little break coming up in a minute. But I have a question for you, Andy. One of the things that I think about when I see what you're doing with the digital twin is, I talked about how I could potentially use it operations live, but how do you? Actually, one of the things that occurred to me was Google Maps, right, and Waze and the data on there, and do you? Question number one is, do you have an integration where you pull data out of Google Maps somehow, or source any information from these kind of public repositories to support what you're doing? And then B, could you envisage a future where Operations Live might be a consumer-facing tool, and people like me could really actually use it? And yeah, I guess those are the two questions. Thanks.
So we are developing other applications within TFL. We have this app called TFL Go, which we're basically delivering information about routing on the public transport side of the system. The problem from the road side is how to connect what happens on the roads up with the information that we have in TFL Go. And there's questions need to be answered there, because one of the things is we don't actually know very well how people consume roads. How do you think of your trip on the road? Usually people talk about road marks, like I'm going over to Tower Bridge or some other, but how you would begin to group that up in a context that made sense to you for doing your trip, there still has to be quite a bit of thinking happen there in terms of linking that up. So most of the data that I showed you is what I call snap to network data, data that's formulated around each of the 60,000 links. The next big challenge for me is, how can I take telematics data or data from social apps that says I went from A to B? How do I overlay that on my road system? Because that is actually a richer picture, a more detailed picture that crosses parts of the network that I haven't designed in my system. My system has 60,000 links, mainly because that's where we have data. There's actually a very large portion of London's roads, about 11,000 kilometres of it, that's mainly made up of residential streets and very small minor roads that we don't, in terms of traffic management, take note of. But if you were travelling on an e-scooter or something else, might be really important to you. And so, that's a problem that I haven't actually solved yet, and thought about how do I bring that into my framework. Now, I've done some provisional thinking, otherwise I wouldn't have developed around the route I've got. But there's this idea that you're always building, and it's always agile, and it's always, what's the next thing that you move on to? So some of the issue is, some of it's conceptual, thinking through how do I represent roads data in a way that's meaningful for the customers. That has to be done. And then, how do I link that up with understanding how you use the public transport system, because that's important to us. If there's a large tip out of people from a train suddenly because the line's closed and they're all coming out at Blackfriars Bridge, and there's a certain big ped demand on that junction, our guys want to know about it. They want to be able to provide more green time to deal with the peds that are tipping out of that station, so there's a bit of work to be done here. But the idea is, have you open architected? Have you been agile? Have you thought through, and left capability to bring in trip layers? So I've got this 60,000 links. How do I bring in these 3.7 billion? Well, obviously, these trips, how do I bring that data to bear on top of my... So I've begun to think, yes, what's important is those trips where they intersect with the roads that I've got, but I also want to know something about the origins destinations, because that's how we work our traffic models. So I'm already thinking about linking my framework links with our traffic models. well, I will think about incorporating the trips data in there, bit of thinking. But the idea is that you have open architecture to help solve those problems. Bit of work to get there, not least of which understanding how you consume the road network.
Thank you, Andy. Oh, well, we've got a full room of people, and this is the least amount of questions we've had so far. So yes, I can see one at the very back there, Suzanne.
Oh, yeah, very nice presentations. And my name is Steven, and I attended the Graph Summit in 2019, and in a virtual one, and got certified as a Neo4j developer. But I haven't used like Neo4j for quite a while. But it's good to reconnect with this wonderful world and listen to this. Amazing stories and the insights. Actually, I'm currently working on a data governance project dealing with metadata, and try to optimize the data lineage, try to like improve people's like trust in the data system people use. So, and I heard the word metadata multiple times in both like Andy's presentation, also in the graph. Like knowledge graph presentation. So my question is there any like insights or practical guides on how we should capture and manage the metadata, and how to leverage Neo4j's capability of helping us to build some understanding about what we are managing? Yeah.
Yeah, so this is like the metadata management piece is one of the trickiest aspects, and it's not necessarily from a modeling perspective, it's data collection, right? So some of the organizations I've been working with where like this ability to really, like you've got the regulator can walk in and say like, you need to prove to me you've got control of your environment, right? And where are you getting this data from? Which comes down to like the data lineage and the metadata understanding. Now, some of the ways that they've started to pull this, I was working with one organization, and they were, I can't remember exactly, but they were taking Oracle, they were taking a snapshot of Oracle, they were then recompiling it with certain flags on to dump out from the stored procedures what fields and what tables these basic PLSQL was looking at, right? And that was one of the ways that they were then being able to abstract and understand when you triggered a certain query, right, to extract data, what were you actually touching under the hood? So they were then doing two parts, which was and they recompiled it like every week, every night. I can't remember exactly how often, but pretty frequently, to basically take a dump of that database, to look at what is currently the kind of the true landscape. The other one that we've been seeing is like with enterprise grade tooling, such as like the Informaticas and the Ab Initios, they have a lot of metadata management that's baked into the tool. So when you created these flows, you basically can store them into a metadata management tooling. Now that has an API, right? At which point we're seeing a lot of people scraping those toolings, because inside of those ETL layers, you've got a lot of that transformation, right? So you've got a lot of them taking it from, one record or, number of different fields, doing certain aggregations or manipulation of that data, and then either dumping it into another reference table before it then gets picked up and shoved somewhere else. So there are, and then there are other tooling out there that are trying to do this like automatically, where they will just go and like scrape the world. The honest answer is there is no silver bullet for this. Like, it is hard work, right? And this is the bit that we're seeing this iterative approach by taking from the ETL tools. Now the other one that they're using, Kafka or these streaming technologies, now they've got all these like schema components to them. So then they're scraping again APIs. They've got these. On top of this streaming technology, you've got this ability to define a schema, who's a consumer, where's it going, and then some of the really advanced stuff we're seeing organizations do is to do it in reverse. Like, we know we have the data, we know how the tables, but we don't know how it moves around the organization. So one bank is trying to re-engineer that by taking in every single table from their data warehouse, doing profiling and similarity between the names of a field. They then profile the data inside of that field, inside every single table, and then they go, okay, well, if we've got a 90% similarity of data in one table with whatever name, and it's 90% the same as this other table with this other field, do we think they're the same, right? So that's a much more analytical approach to taking it and basically saying we haven't really got any clue what we're doing. We're just going to try and like debug this retrospectively by looking at that. So I'm sorry to say there's no silver bullet for this. I wish we could say we've got a product, just come and use it. But the honest answer is because of the diversity inside of an enterprise, you've got about 1 million tools for every kind of unique thing. It takes a lot of hard work on re-engineering it. But this is where, when you've got reason to, reg programs, etc., it really works. Now the side effect of having that is reusability. So one Japanese bank started to go on this from a reg perspective, and then they started re-engineering, saying, right, now they use it as a discovery platform. Because someone would say, I need to look at trade analytics. Right, well, I'm not, I'm a business intelligence, person. I don't really understand what makes up a trade, what's the metadata. So they then started to use the reversal of the data lineage to power data discovery. Right, so where should I go get this data from? Is there already a materialized view I can consume this data? Who was the data owner? And they built this amazing little fancy web app on top of it with basically just a big ass search bar saying, this is what I'm looking for. And then they were very clever about abstracting away. So if you were in one part of the bank, you would talk about one thing in a certain way. If you were in a different part of the bank, you would talk about the same thing in a different way. So they basically abstracted that with this idea of a taxonomy per business unit. So it all kind of interlinks with itself, and mostly it comes from like the fundamentals of we've got a problem, we need to fix it, we're going to get fined or sued. Or in a GDPR perspective, like you will get fined because you don't know if you've deleted all that data, where does all that data come from? And so a lot of it is like re-engineering that world.
Can I pick up some?
Yeah, go for it.
Pick up some practical angles. Yeah. So there are a number of things that I do in our setup in terms of actually managing the metadata that helps make it easier. The first is I run what's called data as a service, and I also run GIS as a service. I have a GIS team, I have a data management team, I have 2 analytics teams. So in the data service and GIS team and the data management team, they have responsibility for the governance and the tables and the structure of the data. That's their responsibility. And just making sure that everything is well governed in terms of understanding, what's your content, what do you have, when was it updated. The other practical thing that you can do in the business, in terms of like responsibility for the data sets, you can shove that back to the owners of the underlying data sets. So one of the things we do is basically we don't take on responsibility for all the updates. We manage that process, but we actually say, come on, you over there in that department looking after the bus stops, you've got a refresh date, do it, and we've got a schedule for you. Will you let them do all the hard work? You just do the collating. The other element that you can do, essentially the hardest part of putting your metadata together, particularly in my context, is your GIS information. And there are spatial tools that you can use. We go to a company called OneSpatial, we use FME workbooks, and what we do is we set up an automated workflow that actually captures 95% of the work, and then you're using your humans to validate the last 5% of that work, but you still need to do it. And the final thing that you can do is actually spend your time sampling and validating and making, by that I mean that you do a data quality check. I'm used to doing this because a lot of the sensors I run out on the road network, they're not totally reliable. I sample about 10% of them per annum. I go out, I get a manual enumerator to check the counts and the count flows. But you can do similar things on your database, because the security and privacy team are turning up. And unfortunately, if you work with AWS, they give you a lot of tooling on board. Whoever you're working with, you've got tooling available to you to make sure that your data's aligned. Use it, just don't get lazy and and not do the hard work.
I think we have one question at the back probably, but we may have time for one final question after that.
Hello there, I'm Chris Mathers. I work with Lang O'Rourke, and I've got a question. It's probably going to be covered by all three of you, but primarily it is Andy. You've spoken about real-time data retrieval, basically. What I'm interested in is the write speeds. You've got all these data points that's going into the database. Does that impact anything? And also, I want to understand the hurdles of implementing a graph database in the early days. If a graph database has never been looked at or heard of by the organisation before.
Can I take a first stab? Yep. I'll give everyone a chance to think about it as well. You know, one of the things that's really interesting when people start adopting graphs is that the first thing that they do when they install the software or run it somewhere is like import a gazillion nodes and relationships. You know, it's like the first import is a couple of billion nodes and relationships, which is not always the greatest of ideas. You know, you really want to be experimenting a little bit, you know, and iterating over stuff. And I would argue that it's very useful to start with smaller data sets to do some of that iteration work, because everything becomes complicated at scale. You know, that's just a law of nature, I think. When it comes to write speeds, I think you're asking a very valid question. You know, graphs are connected structures, right? You need to do more work when you write something into a graph structure, right? You need to not only write the data, but also how the data is connected to other data, right? So you basically need to do more work. So it really is very important that you think about, you know, how much of that work is going to be put into, like, for example, one transaction. You know, how do I do that? People fail very easily when they try to do too much with too little resources, right? I'm going to run this on a I don't know, 1 gigabyte of memory, and I'm going to throw a couple of gazillion nodes and relationships at it. Guess what's going to happen, right? It's going to be a big fat boom, and it's going to stop working. But there's lots of ways that you can manage that, you know, and I think this is one of the things that we can very much help clients, you know, with training, but also with advisory capabilities, just so that you do these things in the right way, you know. And then I think, you know, it's a matter of just understanding what's going on and just understanding all the work that needs to happen to do something in a database, and then that usually works out really well.
I think fundamentally you can't beat around the bush. Like, it's an ACID compliant database. Yeah. Right, we're not an eventually consistent data store. So with that guarantee of that ACID compliance comes an overhead of write performance, right? But then if you look, there was a keynote, I think it was last year, where they did the trillion node graph. And the idea of that is about partitioning, right? So if you look at Elasticsearch, what do? We write across multiple indices to parallelize the write performance, right? Now again, that's eventually consistent, so they don't care about the durability. It will turn up whenever it does. So yeah, like if you're doing, and I was with one conversation yesterday, I think the gentleman was actually here today, they're doing 10 million events a second, right? Well, you know, that's not going to be one node of Neo4j, right? And so there's ways around how do we partition our data in order to get it in there, because, you know, there's certain physics you can't get around, and the fact that we do such aggressive validation of that data to insert it. So there's tricks and tips we can get to getting to faster write performance around the modeling of the data. How do we kind of shard the write process? But fundamentally, because you're writing into a kind of ACID compliant data store versus, as I said, a NoSQL or a document store, you know, there's going to be a slowdown from that side of things.
And to take the second part of your question, which was asking, how do you get this accepted by the business? How do you get a graph database accepted by the business? It's essentially a progression. You basically have put together your ideas and your framework, and then you understand that actually what's driving the business need is actually it wants real time. So the best thing you can actually do is build a very simple, and just taking your idea, you just build a simple business case in the first instance, and you actually show that I can deliver a result that matters. And the very first time we did it was during COVID. COVID happened, there was a bit of a panic. We need to clear ambulances. You know, they had the Queen Elizabeth, what was the centres? They had the Florence Nightingale centres set up. And all of a sudden, I basically was like, build something for me, Andy. And so what I did is I actually connected, answering your question, I connected into Google. You know, I took the live Google data and I basically put it into what was the beginnings of the digital twin. And essentially I was able to demonstrate a very simple case where we had the routes from hospitals to the Florence Nightingale Centre at wherever it was, at O2. I'm just trying to remember the context. And I just built a very simple application that actually said, look, this is the effective journey time now to travel from that hospital to this location at this time of day. And I was, you know, I didn't even have my own data source to do it. I was using the Google data. Turned out it was blooming expensive, but but that's what I did. I built a very, very simple user case. It was just, you know, 13 routes from different hospitals to the Nightingale Centre in real time. And at the time, that's what all the signal engineers needed. You know, if I have to clear a route, I can clear a route. I understand where any blockage happens. And that solved the idea, and hence we went on and built it further and further.
Fantastic.
Yeah, I think the one thing I would add. So I was in a meeting last week, with the CIO of a bank, right? And his default response to everything was, "Yeah, but I can do that in a relational database." Like, you can do it in a relational database. Like, and we're engineers here, right? So we're all very good at our knowledge set. We know how to engineer things. Like, I spent 10 years flattening everything. Like, I can flatten everything, like, beyond belief. But it comes to a point where, when you look at where organizations are having to get to, the way that we talk about this connected world, right? Whether it be from a retail perspective and you need to promote and have that connectivity with the customer, it's ridiculously important, right? And you cannot have that when you've got this data smashed across multiple tables. One example was we were at Burberry and we wanted to cross-sell massively, right? You wanted someone to walk in with something and we needed to cross-sell them to other products. Right, really simple use case. So Burberry went up, and Burberry being Burberry, right, luxury brand, we had some money to spend, which is great. So they kitted out these changing rooms. So they put these massive mirrors, like you'd walk in, these massive mirrors, like lovely red velvet, you know, like drawer, curtain, 2 mirrors down the side, and the idea was you would walk in with your product. Now at the time, no one knew what you had, right? You just pick something off the shelf, looked to be the right size, you would walk into a changing room. So you'd walk into a changing room, we basically put a delay into this thing. We then, after about 30, 60 seconds, as you probably hopefully got the garment on, suddenly the 2 mirrors on either side would flip. And what it actually was it was then that item walking down the catwalk. So if you walked in with a trench coat, suddenly you would see a model, male or female, depending on which trench coat you picked up, because we knew exactly what you had. You walk in and then suddenly there's this model. Then what would happen is a sales associate would get pinged, right, saying there's somebody that's just walked into a changing room A with a trench coat, blah, 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 of a size XYZ. This is the look. This is the estimated size. Go and take them the rest of the outfit, right? And so this is when you start to, then they start to get clever trying to pick up the customer and the user and the purchase behavior. But you can't do this like recommendation and understanding this holistic view of a person without having that classifies that relationship as a first-class citizen. And when you get into this world of that interaction with you and that organization, like, it has to be back to the knowledge graph piece. It has to be a knowledge graph. Like, the best knowledge graph in the world is google.com. And that's where we all want to get to, which is like, we've just got a search bar. And I'm going to put, as human nature does, a very verbose, random question in there. And you've got to try and guess what I'm getting to. Now, try and do that in a relational database, where you're joining left, right, and center, or a document store where that understanding around that person isn't explicit. It gets very, very difficult. So I'm spending a lot of time at the moment working on like advanced methods of communication between a customer and an organization, potentially a chatbot or other kind of mediums, but I need to very quickly be like, okay, I know this is Michael, and I need to be able to transition through his whole interaction, right, from, okay, we've just found out that Michael has just been on an FAQ because he's lost his card, and suddenly he rings up, guess what he probably wants to know about, right? But that's this, again, this ability for you to join this data between your website traffic or your chat history, your transactions, your whatever it is, depending on the industry. And that's where this idea of a knowledge graph comes into play. And that's when you get to, but I can do this in a relational database, where you can't, if you want to get your organization to that next step to be that thought leader in, you know, making sure you're still around, right? Because there are a lot of companies that we know of that no longer exist because they didn't innovate, they weren't on the front foot. And I still get meetings where you turn up and it's like, we're a graph database. And they go, brilliant, so what type of visualizations do you do? I'm like, no, we're not line graphs or pie charts. We are like graph theory. And they're like, oh. And you just see some people like switch off and other people are like, oh my goodness, I totally get this. Let's go on there. So we're still on that road of evangelizing. Obviously, from back in the day when Rick was first here, there was a small number, and you now look at how many people we've got in front of us. There is a community, and if you look at also the academia, the number of kind of quotations that you've got with graph databases going through the roof, because that connected world is becoming such a critical part to any industry, from finance to telcos to energy to automotive. It's crucial.
Thank you.